Hey everybody, it's Mr. N, and we are going to do this next lesson on the mid-segment theorem of a triangle. So right here, let's go ahead and read this, and it says, the mid-segment of a triangle is a segment that joins the midpoints of the two sides of the triangle. So every triangle is going to have these three mid-segments. So mid-segment, I'm going to join this midpoint with that midpoint. And then you can also join this midpoint with this one, and then this midpoint with that one. So those are your three mid-segments, just depending on how you're looking at a triangle. And since it's a mid-segment, this XP will be congruent to XQ, YQ and YR, and ZP and ZR, those will be congruent as well. So something happens that's pretty interesting when you do these mid-segments. What ends up happening is this piece from X to Y will be parallel to this piece from P to R. So this mid-segment is parallel to the base of that triangle. And not only that, this mid-segment will be half the length of that base. So if this base from A to C, say, was 10, then the mid-segment, D to E, would be 5. And that's pretty much the lesson. There's just two things that we talked about today. One is for the mid-segment. The first one, we said that the mid-segment will be parallel to the base. And then the second thing, it'll be 1/2 the length of the base. All right, so now let's just do some examples so we can see how this works. So we're going to slide this up, and we're going to do some of these examples right here. And it says, use the triangle mid-segment theorem to name the parts for the figure. A mid-segment of triangle ABC. So we just have to name a mid-segment of triangle ABC, and that would be DE. We'll just do the one that's shown. Then it says a segment parallel to AC. Well, parallel to AC, that would also be DE. A segment has the same length as BD. The same length from B to D would be A to D. A segment that has half the length of AC, well, that would be DE. DE would be half of what AC is. And a segment that has twice the length of EC, well, that would be B to C. So if this is EC, BC would be double that. Okay, next problem, it says complete 6 through 13 to show that the mid-segment GH is parallel to DF and that it's 1/2. Okay, so since we have to show that it's parallel to it, what we're going to do is find this slope, right? The slope from D, which is right here, to F. This slope equals 0. It's a horizontal line. I don't even need to calculate it. Well, then look at this. The slope from G to H is also 0. So these two are parallel. And then over here, for number 6, it says use the midpoint formula to find the coordinates of G. Well, the coordinates of G, we can just pretty much count it. We don't need to technically use the midpoint formula because we're going 0 plus 0 over 2, so that's 0. And then 0 plus 4 over 2, and that's going to be at 2. So it's at 0, 2. And use the midpoint formula to find the coordinates of H. Again, what I'm going to do this time is I will use the formula because I'm going to find the midpoint from E to F. And the midpoint here will be 0 plus 6 over 2, and then 4 plus 0 over 2. So this will be 3, 2, and sure enough, it's at 1, 2, 3, 1, 2, right there. Okay, now find the slope from D to E. The slope from D to E is going to be, D to F, we had said that this is going to be 0. And the slope from G to H, let's move this up a little bit here, is also going to be 0. So these two are parallel, and this is the midpoint right here. So now we can find this distance, and it's on the next page, so we will continue on there. And so if two segments have the same slope, they are parallel. So yes, they are parallel. And then use the distance formula to find DH. Sorry, I meant DF. And we could just count that, and that distance was 6. And then same thing with G to H. We can just count that, and that was 3 since it was a horizontal line. Otherwise, you would have to use a distance formula, and you had the point 0, 0, and then 6 comma 0. And so then here the distance would be the square root of 6 minus 0 squared plus 0 minus 0 squared, which would give you that 6. And then you could do something similar here, which would give you the 3. So does GH equal 1/2 of DF? Yes, it does. All right, on the next problem, let's move this up a little bit. It says use the triangle mid-segment theorem and the figure for exercises 14 through 19 to find each measure. So ST right here, oops, let's get the pen, and we've got from S to T. Well, if this piece from P to R is 24, then S to T will be 12. P to U is that one right there. Again, if that's 24, we know that this is a midpoint, so that will also be 12. And then Q to R, well, now this piece right here they're telling us is 11, so Q to R will be double that, which is 22. And the measure of angle SUP, and that's going to be 55 degrees, because if that's 55, these two will be parallel down here, right? Because that's a mid-segment, so that's going to be parallel to this. So these are alternate interior angles. And then the measure of angle SUR will be, if this is 55, that's going to be 180 minus 55, because, again, this is parallel, so you're going to have supplementary angles there. So that's going to be 125 degrees. And the measure of angle PRQ, PR to Q, and that's right in here, P to R to Q, that's also going to end up being 55 degrees. And again, that's because this will be 55, so that'll be 55, corresponding alternate interior this way. Multiple different ways of thinking about it. All right, and that was it. So this was a quick lesson. Hopefully the mid-segment is not too difficult for you guys. Hit that like and subscribe button, and I'll see you guys in the next video.